Hey, sorry guys. I was running a little late today. My father-in-law is over and he brought some stuff up that I had to unload from his truck, and then I looked at the time and I'm like, it's five past 3. So I don't know, and now we're gonna hear Archie barking like crazy. Hold on one sec, let me mute this. There we go. Alright. So let's see here. Oh, that's email, notability, and then we had that's math 12. You guys are working with this one. All right. I don't know how many people are here. I see Mariah, Sierra, Shannon just messaged. Nobody else is popping up in the feed. I'm going to assume there's other people in here, though. So I might just kind of go with it, and then if anybody misses, they can just watch the playback. I talked to a few students. Sierra, they should be sending out a message within the next couple of days. You might be getting a letter, or they're going to do that huge phone call where Mr. Crandall talks, and they're going to talk about how returning iPads happens. I think the first day iPads can be returned is going to be June 16th. I don't know if the school, nobody told us, so I don't know if you guys are supposed to be driving up to the school and they're going to do some kind of drop off, or if the school is going to be driving to your guys' house to pick them up. I don't know. I'm waiting for the phone call too because they haven't told me anything. If we're going to pick them up, then I'm going to try to drive down and help out. So once I hear more, I'll definitely let you guys know. Oh, now the viewers just blew up. Okay, so it looks like everybody's able to get in now. So, sup. So I guess I'm just going to go into the lesson. I had a few suggestions, and it's up to you guys. I was going to do one day at a time and then give you guys Thursday off, but I had some suggestions asking if we can just do the 2 pages today, and then I won't have to teach a lesson tomorrow or on Thursday. And that way it just gives you guys the opportunity to catch up with anything that you're missing or what you need to complete. So I'm okay with that. If you guys are okay with that, if it seems too overwhelming, you need me to stop, I guess you could just come back and watch the video later and just ask me questions in Zoom. But there was 4 questions on the last page I was going to do with you guys, and there was 2 questions on this page. So essentially we'd be running through 5 questions. So I'm okay with that because these 2 are pretty much the same. And on the back page, they are review questions, so we might be able to go through them a little bit quicker. So this second page is exactly the same as the first page. It's just going into complex fractions. So on the first page, we just had a simple 1 fraction. On this page, it's 2 fractions. So the last step is going to be the same as the first page. The first step, you guys may recall, we did something called an LCD. And we've done, I mean, that was all Unit 10. So before you do an LCD, the recommendation is to look at the denominators and make sure that they are factored, because you can't find the LCD unless you know what those denominators are. So what I'm going to do is I'm just going to factor those denominators out. And you only have to do the denominators. You don't have to do the numerators. So I can factor out this bottom by using dots. So I have x squared minus 25, which is going to be x plus 5 and x minus 5. And then on the bottom, it cannot be factored, so I'm just leaving it the same. Now when you guys look at this, you guys should be able to see there is an easy LCD here, because when you guys do the LCD, you're supposed to look at anything in the denominator that's the same. Well, the part that's the same right now is the x plus 5. So first you look for the parentheses that are the same. Second, you're going to try to look for any parentheses that's not the same. So we have the x plus 5, and then the other one would be x minus 5. So this is our LCD. Now what we're going to do is just take that LCD and multiply it to the top and bottom. Very similar to what we were just doing in the last unit when we were doing the trig stuff. If it helps, you can put it all over 1. And I'm doing it to the top and the bottom of the fraction. Now that I have that, I'm going to move this over a little bit more so it's not confusing. Now that we have that, you guys were told to do something called cross-reducing or cross-canceling. So I'm going to look at the top part of the fraction. I'm just looking up here, and I'm just looking to see if there's anything that's the same on the top and the bottom. Is there anything the same on the top and the bottom? And you guys should see that you guys have an x plus 5 the same on top and bottom, and an x minus 5 that's the same on top and bottom. If they're the same, they just cancel out. So all we are left with on the top of the fraction now is x plus 3. Now I have to do the bottom. So now if I look at the bottom part down here, the only thing that's the same on top and bottom in both of those fractions is the x plus 5. So the only thing we have left on the bottom down here is x squared minus 9 and x minus 5. And now we're doing a problem like we did from the first page. So now after you do all the LCD, after you cancel stuff out, now you just have to factor everything and see if anything can cancel. So there is still one more part that can cancel here, or that can be factored, and that's the x squared minus 9. So technically, we still have an x plus 3 on top, but that x squared minus 9 can be factored using dots, and we can break it up into x plus 3 and x minus 3, times it by x minus 5. And again, we're just looking to see if there's anything that's the same on top and bottom, and we should see that we have those x plus 3's that are on top and bottom. Be careful here, because I noticed some of you guys did this back in Unit 10. If they cancel out, the answer is always equal to 1. So we still have a 1 left up on the top here if it's canceling out. It doesn't just disappear and become 0. So my final answer is going to have a 1 on the top, and we still have x minus 3 and x minus 5 on the bottom. So this part right here is exactly the same as what we did yesterday. The only part that I added on is the LCD stuff that we did back in Unit 10. Okay? So I'm going to run it back with you guys. I'm going to do another problem just like this to make sure you guys are good. And then you'll have the other 3 that you guys can do for the assignment. Oops. And if you got a question with that, let me know. Kylie, I see that you're in here. I just wanted to ask you a question. I shot you an email back. Did that answer your questions? Or do you want to meet up later? Oh, this one we could just do an LCD. So in number 2, it's going to be the same type of problem, and we just have to look at all the denominators again, right? So if we look at all these denominators, you're going to notice that none of those can be factored. So what I'm going to do is just write down my LCD. So my LCD in this case, I know I have to have 2x plus 1 because I do have something that matches. So 2x plus 1 is going to be one part of the LCD. And I'm going to put in parentheses because you're always multiplying everything that's left over. And then the last part would be the x is what's left over, so we just have to multiply it by x. And it doesn't matter if you put it in the front or the back. All right, Kylie, I could set up a little time for you if you want to sit down and Zoom at some point. Just shoot me an email. It shouldn't take us too long. So as far as this x goes, doesn't matter where you put it. You can put it at the front, you can put it at the back, doesn't matter. All I want to do is just take that LCD and I want to multiply it by everything. So I have 2x plus 1 times x. Oops. And you got to make sure you're doing it to all fractions. So this time we have 3 fractions. I don't know why I keep putting extra parentheses on. And again, if it helps, you could put it all over 1. And just like before, we're just trying to see if we can cancel anything out on the top and bottom. So I'm going to zoom in a little bit so it's easier to see what I'm about to do. If you look at the first fractions, we have the 2x plus 1 over 1 and the 1 over x. The only thing that's the same on top and bottom here are the x's. So we can cancel those out, and we're just going to be left with 2x plus 1. As far as the second fractions go, we have the 2x plus 1s that are going to be the same, so those can cancel out. And we're just going to be left with negative 1 times x, which is just negative x. And now I have to do the bottom. And again, you guys should be seeing that the 2x plus 1s are going to cancel out. So you're just left with 4x times x, which is going to be 4x squared. Now the last part is just simplify it down the best you can. We can simplify the top because 2x plus 1 minus x, we can do 2x minus x. So we're going to have x left over and a plus 1 on the top still. And on the bottom, there's nothing we can do with that, so it's just going to be left with 4x squared. Well, now at this point, there's nothing else that needs to be factored, so we're good to go. So number 2 is actually a little bit easier than number 1 because we didn't really have to factor anything. So as you guys go through those other questions, just check to see if anything could be factored first as you're going through everything. Okay? Also, I just want to point out, I'm going to jump down to number 4. Number 4, there's technically 4 fractions there. You just have to make sure you take the 3 and 4 and put it over 1. Technically, those are fractions. You just got to put them over 1. And then same thing, find the LCD. Okay? So those last 3 are on you guys. If you got questions, you got my Zoom, you got my email, just let me know. So by request, I was asked to just continue on and just get this whole thing over with so we don't have to do another lesson tomorrow. I'm fine with that. So I'm going to go down to the next page. This page is actually going to be very similar when we start with 1 and 2. But when we go to the bottom with 7 and 11, it's going to be a little bit different because, actually, you know what? It's kind of a mixture. Yeah, 7 and 11 is kind of like how we just started up top, but 1 and 2 is kind of how we ended up top. So it's going to be a mixture of stuff. It all depends on if you're adding, subtracting, multiplying, or dividing fractions. So I'm going to start with 1 and 2 because those are the easier of the questions. All right, so number 1 is a multiplication problem. So before we multiply anything, the recommendation is always to factor first. So it was kind of like how we started earlier. Check to see if anything can be factored. So I'm going to do it for every part of the fraction. So I'm going to start off with 8x minus 32. We can factor that using GCF. So all I'm going to do, I have an 8 that can fit into both of those. So I'm going to pull the 8 out, and I'm left with x minus 4. All right, so now I'm going to factor the bottom. If I go to factor the bottom, I have x cubed plus x squared. Once again, I can do GCF, and it looks like I have an x squared in common. So I'll be left with an x plus 1 on the inside. Now I can go to the next one. And that one, it looks like I have an x squared in common. So I can pull out an x squared, and I'll be left with x cubed minus x squared minus 2 all over, what color have I not used? I can use this one, the pinkish, all over. Again, it looks like we can do a GCF, and it looks like it's going to be 4. Be left with x squared minus 4x plus 4. And now what we need to do is look to see if anything can be canceled out. And I guess we should see if we could still factor, because it looks like a little bit can be factored. We can check the trinomials inside the bubbles to see if they could be factored. If we look at the top part, the x cubed minus x squared minus 2, this cannot be factored because it needs to be a squared. And since it's a cubed, we can't actually factor the top. However, the bottom part, we do have x squared minus 4x plus 4. This can be factored. We can do double bubble with that. And if we do our double bubble, it looks like that's going to be x minus 2 and x minus 2. So technically, this is going to cancel out because I factored it again. And actually, I'm going to put the 4 in front of it just because I don't want anybody to be confused. So now what we need to do is just look at top and bottom and see if there's anything that can be canceled out. Unfortunately, there's no bubbles that can be canceled out in this one. However, we do have some stuff that is similar. We have the x squareds that are the same, so technically we can cancel those out. And technically you have an 8 and a 4 on the bottom. So we can actually reduce 8 and 4 by dividing both of them by 4. So if I divide the top by 4, I'm going to be left with 2. If I divide the bottom by 4, I'm going to be left with 1. So now all I'm going to do to write down the final answer is just write down everything that's left over on top and bottom, and we're done. So I'm going to have a 2, an x minus 4, and an x cubed minus x squared minus 2, all left on the top. All over, I have an x plus 1, an x minus 2, and an x minus 2 on the bottom. So it's not a pretty answer, but that is a simplified version of what we were multiplying in 1. Okay. So that was for multiplication. So multiplication's pretty straightforward. Factor it, see if anything cancels out, good to go. Division is almost identical to multiplication. There's just one extra step. I'm going to write down these 3 letters, and these 3 letters you guys are going to probably recognize. K, C, F. So keep, change, flip. So the first thing I'm going to do is I'm going to make sure that W plus 3 is a fraction. So I'm going to put that all over 1. So now the rule states I have to do keep, change, flip. So I have W squared plus 2W minus 3 all over 3W squared minus W minus 2. Now I'm going to change it to multiplication, and I'm going to flip the second fraction over. All right, so now that's our new equation. Now we're just back to multiplication. That's what we did before. So it's the same expression. We're good to go. So now I just have to factor everything again. So we can only factor the left side in this case. So if I go to factor this first part, it looks like I can have a double bubble, which would be W plus 3 and a W minus 1. Because 3 minus 1 will give me that 2. All over, we got to factor the bottom. This one's more of the tricky trinomial. I'm just going to put the answer out for you guys right now so I don't have to spend the time going through it. But if you guys are having trouble when there's leading coefficients, this is the guess and check method. Don't be afraid to hit me up by email or jump into the Zoom. It's going to be 3W and W, and it's going to be 2 and 1. The 2 is going to be next to the 3, and the 1 is going to be at the end. We need it to be negative, so this 1 is going to be negative, and the 2 is going to be positive. If you were to do the guess and check where you multiply the insides and multiply the outsides and add them together, you'll get that answer of negative W. Now that I have that, I'm just going to rewrite the last part, which is 1 over w plus 3. And now we're just looking to cancel out whatever's the same on top and bottom. So in this case, we have the w minus 1s, and we have the w plus 3s. Those are all gone because they're the same on top and bottom, and we're just left with a 1 and a 3w plus 2. So that one worked a little bit nicer than problem number 1. As you guys can see, it's just simplified to one thing over another, and that's it. There wasn't a bunch of parentheses. Okay? So if you have any trouble with any of the other ones, let me know. It's just all multiplying and dividing. Now I just have to show you the adding and subtracting, which is kind of tying in the beginning part of the first page we did today. That's adding in LCD. So that's the only other part that I got to show you guys. I think you're going to be okay overall, but we'll see just to make sure. So in number 7, again, you guys have two fractions. You're adding them together. The first thing you have to do is find an LCD. There's nothing you can factor here, so that's why I'm going straight to LCD. And in this case, we don't have anything that matches. Now, you can say that there's a in both of those denominators, but the a is tied to the -1 in this second part, so you can't split these up. So I can say that I have an a and I have an a minus 1, and I'm just going to multiply them together. Anytime you're looking for an LCD, you're just multiplying all the denominators together. Okay? So here's the weird part with this one. When you find the LCD when you're adding and subtracting fractions, you don't multiply the LCD by both fractions. You want to make your denominators look like this LCD. We want the bottoms to look like that. So it's a little bit different, but overall when we go to solve it, it's going to kind of be the same. So when I go to solve this out, what I'm going to do is I got to figure out what's missing on the bottom. Okay, so I have an a minus 1. I need to have an a out front. In the first part, I have a 5 over a. I'm missing an a minus 1. So I got to figure out how I can get what I just wrote down in red into the equation. Well, when we do this math, what we're actually doing is whatever you multiply to the top, you got to multiply to the bottom of a fraction. So because we had an a minus 1 missing in the first part, I have to make sure I multiply a minus 1 to top and bottom. Because I have an a missing in the second part, I have to make sure I'm multiplying a to top and bottom. And then I'm adding the two fractions together. Remember when we did LCD for just regular fractions, if I add 1/2 plus 1/3, I can't add them together unless the denominators are the same. If I have 2 and 3, that means the LCD is going to have to be 6 because 2 and 3 both fit into 6. So if I want to add these together, that means I would have to multiply the bottom by 3, and then I would have to multiply this bottom by 2. When you work with fractions, whatever you do to the bottom, you can do to the top. Okay? So that's what we just did down here. Same exact thing, and I'll run it again when we do the subtraction. So now I just have to simplify this. So I'm going to multiply the top. So I have 5 times a minus 1. I'm just going to distribute. My pencil stopped writing. I'm still writing. We'll see if it shows up. Anytime now. There it goes. And both of these are still over a times a minus 1. Now the rule is if the denominators are the same, then you're allowed to add the tops. So you don't have to distribute anything on the bottom. All I'm doing is just combining what's up top. So I have 5a minus 5 plus 3a. I can add the 5a and 3a together, and I'll have 8a minus 5 all over a times a minus 1. and then I'm good to go. So it's a little bit different than what we did on the previous page, but it's not completely different because it's still multiplying stuff out. It's still factoring if we have to. Number 11 is the same type of problem. It's just there's 3 fractions. So I figured I'd do number 11 with you guys because it's the hardest one on here. So I'm going to do the same exact thing. Nothing changes. Make sure that all the denominators are factored first and find an LCD. If you guys need me to go back to the other question, just let me know and I'll zoom out. Otherwise, you can just go back and watch it in the video. So I got to factor everything first. I'm going to have 3 over p plus 1 plus 4 over 2p minus 6 minus p squared minus 5. Now I can factor this one, and I'm going to have p minus 3 and p plus 1. Oh, actually, I could have factored the middle one, too. I wasn't paying attention. That 2p minus 6 can technically be factored by using GCF. So I could pull a 2 out. And I would be left with p minus 3. So when we go to solve this, it's going to be exactly the same as the one that we just did. It's just it's with 3 fractions. So I still have to find my LCD. Make sure you find anything that matches first. So I see that I have a p plus 1 right here. Well, I also have a p plus 1 over here. So p plus 1 is one of the LCDs. I also have a p minus 3 matching. So I could multiply it by p minus 3. And now we just have to write down anything that's left over, and the only thing that was left over was a 2. So what I want to do is I want to go through all 3 of these fractions and figure out what's missing in the denominator. So if I look at the first fraction, I have p plus 1. I am missing a p minus 3, and I'm also missing a 2. Whatever you guys do to the bottom of a fraction, you must also do to the top. Okay? So now I'm going to the second one. I have 2 times p minus 3 on the bottom. I'm missing a p plus 1. So whatever I do to the bottom, I got to do to the top. In the last one, it looks like the only thing I'm missing is a 2. So again, whatever I do to the bottom, I got to do to the top. Okay? So now what I'm going to do is I'm going to rewrite everything. The bottoms are all going to stay the same. I'm just going to write 2p minus 3p plus 1. All 3 denominators are going to look exactly the same. We don't ever have to multiply the denominators out because we want it to be factored in case we can cancel it. We just have to simplify what's on top. All right. So the first one, we have 2 times p minus 3 times 3. So what I'm going to do is I'm going to multiply the 2 whole numbers together first. So if I multiply those 2 numbers together, it's just going to be 6. And now I'm just going to take the 6 and distribute it into the parentheses. So the top part you actually have to multiply out. The bottom part you don't. So if I distribute that 6 now, I'm going to have 6p minus 18. If I go to do the next part, I can do 4 times p and 4 times 1. And if I go to do the last part, I'm distributing the 2, and I'm going to have 2p squared and minus 10. So now our goal is to just make everything all into one fraction and then see if anything cancels out. Okay? So I just got to combine like terms. So I have 6p and 4p can be combined together. So that'll be 10p. I have this minus 18. I have this plus 1. And we got to be kind of careful here because the last fraction's being subtracted. So technically, this subtraction symbol is being distributed to both of those. So if I distribute it, that's really, oops, it's really going to be a positive 10. So you just got to kind of be careful with that as you guys see negatives. So that would actually be a positive 10. So if that's a positive 10, I have negative 18 plus 1, which would be negative 17. And negative 17 plus 10 would be negative 7. And then the last part is just that negative 2p squared. And it's all over what we had on the bottom. And we're good to go. Did I add wrong? Oh my gosh. Thanks, Ella. Ella's right. I distributed it wrong. 4p plus 4. I thought I said 4, but I probably just didn't write 4. So that changes the p. Oh, wait, no, it doesn't change the p. It would change the whole number, right? So it would be negative 18 plus 4 would be negative 14, and then negative 14 plus 10 should be negative 4. And I'm okay leaving it just like this for right now. Thank you, Ella. I missed that completely. All right. So you guys don't have anything as difficult as that one where you guys have to go crazy into doing 3 fractions. It's all going to be 2 fractions. Okay? Just make sure in number 8 and 9 you're distributing that negative when you go to combine like terms. And if you have trouble with what I'm talking about, again, don't be afraid to ask questions. Technically, this packet is not going to be due until next Friday. I do not suggest waiting until next Friday. I suggest trying to get it done sooner than that. But yeah, this was our last lesson then. So I don't have any more Twitch lessons that I'm doing for Algebra 2. Anything that you guys need assistance with, stop by the Zoom. It's still going to be 1 o'clock every day. If you guys want a one-on-one Zoom, let me know. Just shoot me an email and we'll schedule a time because I'm not going to have any lessons in the afternoon anymore. So if you want to have a one-on-one Zoom at 2 o'clock, shoot me a message. I'll do a one-on-one Zoom with you to make sure that you're okay with anything you're missing. Okay? I will probably be shooting out emails this Friday or Saturday, and the email is going to say if you're all set for the rest of the year or if you're missing any assignments. So if you're missing an assignment, I'll just be like, hey, I'll use Ella because she was the last one that talked. I'll say, hey, Ella, you're missing homework number 8. Make sure you get it into me by Friday. It'll just be like a quick little reminder, and it's just me checking up on you guys for the end of the year. Okay? So if you guys have any questions, like I said, email, Zoom, good to go. Sorry you guys don't have to hear any more of my lessons for the remainder of this school year. Hopefully we will be in the classroom at the start of September. My fingers are crossed. Hopefully we don't have to keep learning this way. It is miserable for everyone. But yeah, we'll just kind of go with it. So I will catch you guys all later. Make sure, please shoot me an email, respond back, anything. Just say goodbye to me for the summer, just so I make sure that everybody's okay. So I'll be sending out emails. Just send a reply to me. I don't care how the reply is. If it just says hi, if it just says thank you, I don't care. Just reply to me to make sure, so I can make sure that you guys are all good. All right? But everybody have a great evening. Go enjoy the weather. It's still nice out right now. We might be getting a little rain later. Hopefully it will hold off. But yeah, I want to go back to Sierra. I'm done with this. But all right, I'll catch you guys later.